and then the laboratory. So please be patient, and thanks for the patient listening till now. Thank you.
Good evening, everyone. My name is Dr. Vinay Verghese, and thank you. I would like to thank the organization for giving us the opportunity for presenting our technology. We are from Thermo Scientific, and we will be presenting our technology, which is the Gene Studio S5 system and the GenX system. Our system, you have heard of different principles and protocols of how the different systems operate. Ours is based on our system is based on the system principle of being a hydrogen ion being released each time a nucleotide is bound. So like sir mentioned, so our principle is that each time a nucleotide flows onto the particular chip, these are chips, not flow cells. So each time a chip is placed in the machine, that is our system over here, the Gene Studio S5 system. Now this system's got a way where each time a particular nucleotide is flown through and the complementary nucleotide is bound, the hydrogen ion is being released. Now this hydrogen ion is being registered as a particular nucleotide being bound, and then once it washes off, the next followed by the next nucleotide being come into the procedure. So each time one nucleotide comes through and a hydrogen ion is being released, the system registers as a nucleotide being bound in that particular location or that particular well. So our system works with the fact that we have ionosphere particles. Now our ionosphere particles would be the beads which our fragments are going to be fully coated onto. So this is the cross section of our chip, and this is the ionosphere particle which has the particular strand or target of interest. Now each time the nucleotide or is flown through the chip, hydrogen ion is being released. Now each time the hydrogen ion is being released in the chip, the system, the pH changes. So our system is basically a very sensitive or pH meter. So the idea behind it is to understand that each time a nucleotide is bound, the pH is hydrogen ion is released, and the system registers as a nucleotide being bound in that particular well. Our system, like the previous activity mentioned, that we have got four steps involved. Now it involves the library preparation, and then using our ion chef system, we got our completely automated template preparation, and then we got our Gene Studio S5 system, which is over here, and then our analysis. So the workflow remains the same with all our procedures or all our panels which we have got. So the idea behind it is each panel with this, the library preparation part of it will only change based on the particular assay you are going to be looking at. If you're looking at SARS-CoV or you're looking at metagenomics or microbiome based applications, your particular library preparation will be slightly catered to that particular application. Once that is done, you look at the completely automated system, which is our Ion Chef system. Now the Ion Chef system has the capabilities of completely doing the library preparation, the template preparation and the enrichment completely by automated system, and then it will load it onto the chip, which we had shown earlier. So the chip, once the chip is loaded, it directly takes it into we just have to take this chip into our system. Now our Gene Studio S5 system has got, I'll go through the library preparation with regards to the library preparation part of it. We got our ranging from starting material would be either DNA or RNA. The RNA will go through one more procedure, that is the reverse transcriptase. But once that is done, you amplify a particular target regions, what you're looking at or you're interested in. So once that region is being amplified, you cut off those particular primers off, because you're done with those, and now those regions of interest which you've got, now you have to put them into our sequencing machine to understand that. So that is where we put in our barcodes, and these barcodes are ranging from the X barcode, which can be 1, 2, 3, 4 till 384 barcodes we have got, and then we've got a standard barcode which attaches to the bead. So the idea behind this is once each time you'll be able to assign a particular sample's identity to that one particular sample with using the barcode, and then the particular sample can be analyzed or understood during the analysis purposes. So our procedure works with with the use of emulsion PCR. Emulsion PCR would be using the oil-based technology and using micro reactors. So So the idea behind it is each time our bead, which I mentioned earlier, the ionosphere particles, the bead is got and the fragments of interest is in this microreactor. This is the bubble basically, and it's got all the reactions involved in a PCR. So it's a PCR in a particular bubble, and this particular bubble is going to go through the temperatures of a PCR amplification standard operating. And once this fragment binds to these particular beads and denatures and binds to this particular bead, the amplification starts through the particular bead. And that one particular fragment is made multiple copies of the fragment onto that particular bead. So the idea is one particular bead you have got the ionosphere particle, and the bead has multiple copies of that particular fragment of interest, and you are able to amplify that fragment, and you got millions of beads and of different fragments of interest across the entire chip. So this is the cross section of our chip, which we had shown and we had passed across earlier. So the idea behind it is each time this bead, we put the beads through. Now all the beads are going to flow through and going to land on each of these wells. Once these beads have gone into these wells, respective wells, we would like to understand that particular sequence. So, but in order to get the fact that our beads of interest are only taken through and not any other beads, we will go through a procedure called after emulsion PCR, we go through a procedure called enrichment, and all this is done automatically using our ion chef system. So the hands-on time would be very minimal, 30-40 minutes, and then after that the rest of the things are handled by the ion chef system. So the idea behind it is once this particular enrichment is occurred using our destructivity and biotin complementarity, the particular beads are taken across, the samples which are contained only the fragments of interest are taken across, and those beads which are coated across which are coated with the target regions are going to be flown across the particular chip, and then each individual nucleotide is going to be flown in the particular chip. So this is our ion chef system, which is a completely automated, and this is what the inside looks like, where our chips are loaded here, and our particular the tips and our libraries and our reagents and respective reagents in the cartridge base. So the idea is half a system is cartridge based application. So you just have to put in the cartridges, and even if you're worried about particular misplacing it or putting it in the wrong place also, the system will alert you to the fact that you put it in the wrong situation, and you can correct it accordingly. And this entire thing is run in this system, that is the ion chef system. And this thing can be done, you can use through our library preparation, you can do a template preparation as well as our enrichment, completely automated on this system, with a hands-on time of only 15 minutes required for this particular system. So once you're done with the hands-on time and putting it in the system, you will end up getting with a result of having a chip. That chip is containing your sample of interest, and it's been loaded onto the particular chip of whichever particular size you have taken through. So this is our system, that is the Ion Gene Studio S5 system, S5 Plus and S5 Prime. So the idea behind this is the computational power will be increasing from the S5 to the S5 Prime, but the principle remains the same. So it's a simple principle which I mentioned, that the hydrogen ion will be released. But when it comes to the computational power and the turnaround time, this is the S5 Prime is much faster compared to the S5 Plus and the S5. This is the cross section of what the system will look like. We'll be able to show it to you tomorrow as well, when we are in the stalls as well. So once we'll be able to show, these are all cartridge based systems. So this is our buffers, this is our chip, and the chip goes here, our buffer goes here, then our initialization, the cleaning solutions, everything have got their particular cartridges and their particular places. So all you have to do is plug and play. The idea is you don't have to interfere or intrude into the particular system as much. Our system, which I mentioned, is S5, S5 Plus and S5 Prime, that is the GE Studio. And the flexibility of the system is you don't need to change the hardware. The hardware of the system remains the same, but your applications can vary. So you want ranging from microbiology based applications to oncology or reproductive health, you can always change it and you can use the same system. So you have the flexibility of a 510 chip having a 2 million reads, and you've gone up to a 550 chip which has a 130 million reads. Now the idea is the 510 S5 chip system is able to use up to the 540 chip, and the S5 Plus and the S5 Prime are compatible with all the chips. So once you are able to assign or your particular assay you're interested in, if you're looking at metagenomics or you're looking at microbiome, you have got a particular chip you're looking at. Now, with regards to metagenomics, you'll be looking at a 400 base pair process. You can use till 510, 520 or a 530 chip. And this one's turnaround time is 3 days. So the idea is now we've got another system called the GenXS system. So this system ranges from the Gene Studio being the turnaround time of 3 days, and now we've got a system which is the GenXS. So the GenXS system is a fully automated. Even now you don't even have to. It's a 2-touch point operation. And once you are got the system, this is the extraction system, and this is the GenXS system, complete system. This is a fully automated system. So your starting material would be, you either take your sample from blood or tissue, put it into the extractor. Once you get your DNA, get that into the system, and everything else is plug and play. So you just put in each cartridge and the chip and the reagents, and you just have to do 2 touch points, and then you're set. And within 24 hours, the idea is this system runs and gives you the data within 24 hours. So a single day turnaround time, and this system is completely automated. And right now, this GenXS system has got capabilities of running with regards to the SARS-CoV genomic sequencing, the reproductive health, and the pharmacology-based applications. We are expanding into the reproductive health and other applications as well. So, as I mentioned earlier, this one system is capable of doing multiple applications. So, we are ranging from microbiology to infectious, inherited diseases, or cancer research, or reproductive health, or gene expression. The idea is simple. If you belong to a particular organization or a diagnostic center, might be doing, your department might be doing focusing on microbiology. But you've got another department in your facility itself which is capable or interested in doing oncology or reproductive health or any other particular. So the system can be utilized for those purposes as well. So the idea is you're looking at infectious or microbiology based applications, you run your system for that. Then if you got application which you're looking at is reproductive health or oncology, you can also look at those particular applications as well. So this is some of the examples we've got with regards to the microbiology based applications. So our metagenomics panel which you've got is 16S metagenomics. It covers the 7 of the hypervariable regions, and we've got using culture-free bacterial identification from the environmental samples. We can also use mixed microbial population samples, and once you are able to you get follow the same procedure ranging from library preparation till the sequencing, you will be able to report it using our IAM reporter software. So even in these stages also, we've got people from our field application scientists and as well as GSS as well as our bioinformaticians. So each step we can step by step guide you through what are the procedures. So we got a dedicated bioinformatician who can help you out with the particular analysis. If you're looking at taxonomical assignment or classification, or you're looking at alpha beta diversity, or you're looking at any particular, you want to do a chronograph, you want diagrams, you're looking at particular answers. So all these applications or all these particular setups, we can help you on or guide you through with our bioinformatics team as well. The procedure remains the same. Ranging from library preparation till the reporting analysis part. Another aspect we'll be looking at is the microbiome panel. So the idea is behind the microbiome panel is we cover the 8 of the 9 hypervariable regions. But also we have also found that multiple microorganisms or species have been associated with this immunological or infectious or gastrointestinal issues. So the thing is, these species also have been taken into account and have also been put into our panel. So it is not only looking at the hypervariable regions, but also looking at the particular panels associated with, particular species associated with any particular infections as well. Like certain particular infections, looking from cancer to gastrointestinal or autoimmune, we find that certain species have been found common across the group, and so we've been able to incorporate that also into our microbiome panel. So as I mentioned, it covers 8 of the 9 hypervariable regions, and it includes about the 73 targeted genes as well. So another aspect we'll be looking at is the infectious based aspects, where we have got ranging from microbiome tuberculosis to SARS-CoV and the Ebola, Zika, etc., and pan bacterial as well. So these are some of the panels we have got. Now, if the thing is, if you do not have any of these particular panels, if we have got fixed panels or ready-made panels, we have got an option or opportunity to do a custom option. So we have got a thing called the Ion AmpliSec Designer software. Now that tool is an online tool, it's free. You just have to log into it, and once you log into it, if you are interested in any particular tool, so now these are the details we've got for each of the fixed assays. Now if you're interested in an assay which is completely custom, those applications also can be run by our system. So you're looking at TB, which is these are some genes covered in that. We've got antimicrobial resistance, our pan-bacterial cancer, as well as the SARS-CoV genome. We can range from 2 samples to even actually the 200 in the 550 chip. So the procedure which involves in the Ion AmpliSec, the SARS-CoV genome sequencing, would be the same as as mentioned earlier, which involves the library preparation to the analysis aspects. But you go from the range from approximately 1 nanogram RNA, and then you proceed to convert it to the cDNA, and then run through our system of the library preparation, and it can be done completely automated using our chef system. So once you get your the DNA, all you have to do is put it into the system, the Ion Chef system, and it's completely automated. So you will be able to get the full thing loaded onto the chip, and all you have to do is take that chip and put it into the sequencer. So our panel contains approximately 240 unique markers across, and we have covers approximately greater than 99% of the coverage of the entire SARS-CoV genome. And we have got samples ranging from 2 to 200 samples ranging from our chips. So you've got a 510 to 550 chip. So your flexibility, if you want to quickly report a particular sample, then you've got an option of 510. If you have a large set of samples, then you've got an option of 550. So the only thing you have to change is the particular chip. The analysis aspects would be regarding to the identification and annotation using our panel. So again, as I mentioned earlier, we've got supports from start to end. You want from isolation, you've got our kits ranging from template preparation, and then we've got our reporting as well. And also we've got people support teams from ranging from the application scientists to the bioinformatic teams who will support you and guide you in these particular analysis aspects. So if you would like to particularly identify the particular tools also, we've got tools which are part of the particular our package as well. So it will be all free and inclusive of the system. So the idea is you got the annotation and the identification and the annotation of the particular variants, the alignment as well as the pango lineage, lineage as well will be done. So we've got our thing called the SARS-CoV-2 lineage ID as well. So that is associated with the pango lineage as well. So we got all the ranges from the identification of the variants till the pango lineage. All the analysis can be done in our panel as well. Now we've got an option of custom, which I mentioned. We're looking at ranges from ready to use to on demand or made to order. You're flexible enough to understand that, okay, if you would like a particular panel or a custom gene you would like to design, or you have 5 genes you would like to take in and you would like to design a particular panel, the idea behind it is, like if you want to look at any particular, this is the site you're looking at. If you're looking at heart disease or you're looking at any particular disease or syndrome, you can accordingly design it. If you're looking at a neurological with regards to the inherited diseases, if you're looking at any of these particular genes, you can have a custom panel or a pre-designed panel using our AmpliSec designer tool. So like I mentioned, some of the applications are ranging, these are all the microbiology applications. Now if a person in your department would be like to look at the oncology based applications, I understand most of you are looking at the microbiology aspects, but if your labs have also a tie-up with an oncologist or any other particular thing, this system can be applicable to that as well. So you got a solid tumors, liquid biopsy, immuno-oncology or immuno-oncology. So the idea behind it is you got solid tumors from our BRCA panels, or you're looking at a focus gene panel which covers a 50 gene panel, or if you're looking at an extensive one which is got a 500 gene panel. So you got a range from all these options as well. So all these as well can be run out with a particular system. And the advantage of this is part of the Oncomine assays, and these Oncomine assays give you an Oncomine knowledge-based reporter as well. So once you are done with the particular assay, the Oncomine BRCA, or you're looking at lung cancer, or you're looking at any particular colon cancer, you would get a report. A report will be 2-page, 3-page report, which will give you clearly saying what was the identified variant, what was the particular, where exactly, is it therapy associated with it, which is an FDA approved or ESMO or European based approved as well. So the idea is you will be getting a clear-cut report of saying this is the variant, this is the cancer, and this is the therapy, so the clinicians or the doctors can address the situation at that point. So once you've got that, you can look at the thing where you're going to microbiology-based application, then you've got an oncology-based the next day, and another option would be our reproductive health, which would be all these applications which can be completely supported from Thermo Fisher. So we have got an option ranging from NIPT, non-invasive prenatal testing, to PGT, pre-implantation genetic testing, and we got another option of expanded carrier screening. These are the three basic panels which can be done using our next generation sequencing, and we've got other options as well which are using our qPCR or our microarray system, that is the Cytoscan, and as well as the Cytoscan Optima or Cytoscan 750. So the idea is this is the full covers the full solutions for our reproductive health as well. So if you are looking at any of these aspects, Thermo Fisher would help you, support you all in that particular aspect, and these systems are compatible with any of these particular applications, and you would be ranging from applications ranging from microbiology to oncology to reproductive health, and you can cater any of these applications into your system. So the idea is your system doesn't need to stay idle. If you've got any other particular application or you want any other particular system test to be run, you can run it across in our system as well. If you got any questions, please. Thank you.
O'Grady, sir. He was our international speaker whom we were expecting in the second half of the session, who was actually about to tell us the loading of flow cell and the bioinformatics part of it. He has gained his BSc, MSc and PhD in microbiology and infectious diseases at National University of Ireland. He remained at the university for his first postdoc, focusing on foodborne pathogens. Later, 2 years stint in industry developing real-time PCR-based tests for infectious diseases including tuberculosis. Professor O'Grady then returned to academia, taking a postdoc position at University College London on TB diagnostics. In Jan 2013, he was appointed as assistant prof in medical microbiology at University of East Anglia, UK. Was promoted to associate prof in 2016 and promoted to prof in Jan 2021. He then joined Oxford Nanopore Technologies as senior director of translational applications. His research continues to focus on the rapid detection and characterization of infectious diseases to maximize community and patient benefit. We welcome you, sir.
Thank you for coming here. And I had a discussion. He is going to talk with us tomorrow. This would be the first lecture. This would be the first lecture. The first thematic lecture will be his tomorrow. He has devised kits for sequencing. That is how it is. Yeah. So that is what he has done, and he would be discussing all those things tomorrow in our conference itself. So right now, what happened was we took his topics, so he doesn't have any topic left. So what I requested him was he has what he did to begin with was that he is a very early adopter of sequencing technologies. So I have requested him that if he tells us about that particular journey of how he started with sequencing with Nanopore, of course, and how it changed the course of his life also. So if he can tell us something about that. Many of the young scientists here would feel that they can also go in that particular way and can do something with that. So please thanks.
Hello everyone. I hope you've had a good day at the workshop and that you've learned a lot about Nanopore sequencing. I guess what I'll talk to you about, you've heard a lot about my career already. That was a rather long introduction about me. But I think I guess what I wanted to get across to you is that, you know, I started using nanopore sequencing in 2014, and I'd never used the sequencer before that time. And the nanopore sequencer was the first sequencer I ever used, and I was an academic at the time. I was a lecturer at the university, and I was doing some research, and I decided I wanted to use nanopore sequencing to do some work on infection diagnosis. And I had spent my research career working on infection, and I wanted to try to apply a new technology to this area. And this area is called clinical metagenomics. So I started to work in clinical metagenomics using that sequencer, and I'd never used Illumina or Ion Torrent or any other sequencer before I got access to that nanopore sequencer in June 2014. And you know, a year later, I was already giving talks at nanopore conferences, and I published papers in Nature Biotechnology on that topic. And I just wanted to say to you that I think it's really easy to try to, you know, to take on new technologies and to apply them in your fields with a new slant, and that allows you to you know, progress rather rapidly in your field. Don't feel that you need to be a world expert to begin with to do well in these fields. And I think as young scientists, you know, when you apply new technology, particularly new technologies, into your fields and use them in new and interesting ways, that you can, there's a lot to gain. So I would say, in my experience in my career, is to be an early adopter of new technology is a great way to push your career forward. So some people say to me there's two types of scientists. There are scientists who are, you know, disease type scientists or application type scientists, or there are, you know, people who are technology driven. And so I suppose I was always a technology driven scientist. So I think even if you're not, I think it's great to be, but like by the fact that you're all here, you are technology driven scientists. So I think that's a great thing, and I think if you keep an eye on what's coming all the time and find new technologies to work with, and they can help you really progress really quickly in your career. And they helped me progress quickly in my career. I went from, you know, sequencing my first sequencing with Nanopore in 2014 to, you know, from a junior lecturer to professor in 6 or 7 years, and then to join the company eventually. So now I work for Oxford Nanopore, and I made that decision, you know, just over a year ago, because I thought the next thing I wanted to do was, I was kind of tired of developing tests in an academic context and writing a paper, and then that was it, and I couldn't see them get used by patients, and so I wanted to take the next step and get tests used in the NHS in the UK and to get them used around the world. What I'm currently working on is a test for tuberculosis and drug-resistant tuberculosis. And that, in my opinion, is a very important thing to try to do, and I know it's a very important disease here in India. So, you know, our plan is to develop this test along with the WHO and find it and get it used globally. And so, you know, I find that very exciting and a great way to, you know, translate my work from, you know, bench to bedside, as they'd say. And my title at Oxford Nanopore is Senior Director of Translational Research, which is exactly what I've always tried to do. So, I guess in the middle of all that, the pandemic came along, and I used my sequencing skills that I developed over those few years before the pandemic to sequence. In our institute, we sequenced over 100,000 genomes, SARS-CoV-2 genomes, and you know, it's great to be able to use your skills as a scientist. It was the first time in my life anyone cared about diagnostics. I worked my whole life in diagnostics and nobody cared, and then all of a sudden everyone in the UK was a diagnostics expert. They all knew about PCR, qPCR, and they all wanted to talk to you about it. Papers wanted to talk to me, the news, the media, etc. And so, you know, it was a great time to be able to translate your work in an area you didn't think you would. And, you know, I'm not a virologist, but we worked hard and worked fast in that area and did well. So I guess my message to you guys is that, this, come to a workshop, and that's how I started, just by picking up Vinay and giving it a go. And I think there's loads you can do, and to apply it, and to apply it potentially in your research, but also clinically, and that you can, change things by doing that. So I'm going to talk tomorrow about the applications that we are developing in TB, but also in bloodstream infection, in respiratory sample testing, respiratory metagenomics, pneumonia. And I look forward to that, but until then, I hope everyone has a nice evening.
I request Dr. Kalyakate sir to please felicitate Dr. Justin. To please propose the vote of thanks.
Good evening, one and all. I, Dr. Nyamtaji, on behalf of organizing committee, would like to propose vote of thanks for today. As famously quoted by Benjamin Franklin, tell me and I forget, teach me and I may remember, and involve me and I learn. With this belief, our organizing secretary, Dr. Rajesh Kalyakate sir, enlightened us with his lecture. Thank you, sir. What do you want in a teacher? We often ask ourselves. Someone who says, I got your back. Thank you, Dr. Rasmita ma'am, for your informative lecture and always having our back. And to Professor Justin Verghese sir, thank you, sir, for your brief, informative and inspiring life lesson. To Mr. Sivaji Manti sir, for illuminating us about Illumina. And also to Dr. Kamlesh Janki sir, in true sense, a philosopher, someone who loves teaching and learning. Thank you, sir. To Dr. Vinay Verghese sir, thank you, sir, so much for your informative class. Thank you so much, Poonam ma'am, Reena Katke, Vishal Rashti, for your enthusiastic and supportive work. Thank you to all the professors, lecturers, and the seniors present here. And special thanks to my batch, that is to PG batch 2022-20, infamously known as the famous COVID batch. Thank you. Without you all, I would have been able to do anything here. And also, I would like to specially thank Dr. Jahangir Das sir, who is a living example of the point. There is no age for learning. Thank you so much, sir. And thank you to all the delegates present here for your patience. Since morning, I know you have been here since almost 12 hours. So thank you so much. Thank you, everyone.
Sir, Dr. Justin, Dr. Jangida sir, to please come onto the dais and distribute the certificates to the participants. Is Vivek Shinde around?
Saida Siddiqui. Savita Zada. Supriya Siddiqui. Swati Bise. Swati. Seema Bisani. Santosh Kodgire. Shruti Sabni. Sneha Sharad. Shri Krishna Joshi. Shri Krishna Joshi. South African Shweta. Rashmita, come in. Come on the stage. Daura. Stand up, please. Ranjana Mati. Rupali Suryavanshi. Pratima Verma. Priyanka Samant. प्रतिभा माने, प्रशांत कुमार, प्राची प्रिया, and I am pronouncing it right. No, sir. Sorry. So what is it? It is Pueri. So Pueri. Kerala? And which color? He was the first in there. And I was the last in there. Standing here. Patare Chetan. Priyanka Prasad. Dr. Prakash Wapmare.
You have a photo later on with us, both of us.
Yeah.
Afterwards, you have a photo with both of us.
Priyanka Thora.
For us, it's a rare moment. We are coming from Chennai and working in Akola.
P.L. Kashyap. Patel. Narendra Patil. Welcome, Narendra. Madhusudan Ganveer. Vidya Arjun Wadkar, our very own associate professor. Yeah. She was very insistent that she has to attend. Kinjal Chaman. Dr. Kiran Munne. Dr. Komal Kulkarni. Ispita Haldar. You have to come from the background. You're studying here. Dr. Jayashree Petkar. Dr. Jaydev Bhandar. Sayana. Dr. Jyoti Bade. Dr. Gauri Yadav. Dr. Geetanjali Sakre. Dr. Divya Kadia. Amisha Datta. Amitesh Datta, sir. Amitesh Datta. Dr. Anjali Ambekar. Anjali Ambekar. Dr. Anna Leonita Fernandez. Dr. Anuja Gadkari. Dr. Anushri Kain. Dr. Asmita Akarte. Jyoti Moses Chandani. Correct, it's correct. Chandani. Dr. Amit Malviya. Dr. Krupa Bhulia. लेकिन डायरेक्ट वहाँ से ही आया होगा इधर कोई कॉलेज में नहीं डायरेक्ट वहाँ से डॉक्टर प्रदीप कौटिया सर ने डॉक्टर विशाल राठौर Anybody else left? Oh my God.
Yes.
Blank one, you can write anything. अरे ऐसा मत लेके जाओ. चलो. Anybody else left? Nobody? Nobody. So I think I thank you all. It was a nice time. 12 hours. 12 hours. I think we took 2 points from MC. 2 points are not enough, I suppose. But then we had all the technologies were dealt with, and I thank Illumina there, and I thank Ian Doran, I thank High Media, and I thank all of you. It was a really nice workshop for us. We were very happy. Sir. I want to give this to the youngest of all the participants. Just the youngest, 75 years old, and yeah, sir, yeah. So I think we'll meet again tomorrow in the morning, and Justin will be there for his lecture. Welcome to